Thank you very much. And we're going to go into a session between now and lunch, which will be a number of talks from speakers from practical data situations, different perspectives and use cases for anonymisation. So each speaker will talk for about 13 minutes, and rather than try and fit in questions between each talk, which I think will inevitably spill us over into lunch, we'll try and keep it so that we've got a bit of time at the end of the whole session. So if each speaker can just turn over once we've thanked each speaker for their talk, then that would be great. Okay, and our first speaker is Brendan Ludden from Vodafone.
So, thank you, Mark. So a very warm hello on a cold day. My name is Brendan Ludden. I work at Vodafone, and excuse me, a bit of a cold. I look after the technology side of an area of our business called Location Insights. It's a relatively new area, and it deals with the use of anonymized and aggregated location network data from the mobile network to understand how people use space. We're very strong focused on the transport industry at the moment, so I'm going to focus on that. Now, you're, I guess, a room full of anonymization experts. I say anonymized, and what I really mean is pseudo-anonymized, right? So you can fill that in for the whole talk. Otherwise, it'll be twice as long saying the word pseudo in front of everything. So it's all about big data. It's all about analytics. And if you go to Wikipedia and type in analytics, this is the first sentence of that section. And I particularly like this sentence, especially that it calls out patterns, the word patterns. And patterns really are important to me on two counts as a business. On the one hand, that's where the value is. It's the aggregated view of combined behavior. That's where the value is. It's not in the individual data. And on the other side, aggregated patterns by their nature provide a level of privacy to the underlying data, the people whose data you're using. So that's that combination of value and privacy protection is very interesting in a business context. So privacy, of course, it's fundamental to the customer relationship, right? First and foremost. And at Vodafone, we have, approaching 20 million customers, and at the heart of our customer relationship is respect. And as part of that respect, even if we're using anonymized, aggregated data from our customers, you really do need to make them aware about what you're doing. Yeah, you're using the data for these purposes. And not only make them aware, but also give them the option, the choice to say, well, I'm not comfortable with that. No, thank you. Please take my data out. So we have an opt-out mechanism. It's simple, it's immediate, it's free. You're a Vodafone customer, you can opt out at any time. And of course, if you're handling data, personal data in any shape or form, you need to implement the highest levels of security. And a key part of that is getting the anonymization right. And I'm going to show you what we do in our Location Insights infrastructure. A little bit about the data itself. So this view here, I'm going to focus on the transport industry here. This view here, that's the view from the network from a single device. And it's my device, so no, don't have to worry about whose data is. That's my data plotted onto a map. So it's location data. And it's data taken from about 7 days observations. And as you can see, it shows where my device goes, right? Now each of those individual red circles, they're the coverage area of a transmitter in our network. So if my device is connected to that transmitter, what I can say is my device must be somewhere within that red circle. Okay? It's kind of key thing to understand that. And as I move around, my phone is it's making phone calls, it's receiving text messages, it's setting up data sessions to get email, and it creates, if you like, a set of digital footprints behind me. And those digital footprints are individual events on our network that we see on the network. And in Location Insights terminology, we call those sightings. And I want to talk a little bit about the detail of that. That's the building block of our whole business, the sighting. And the sighting has three components. The first component is the identity of the device. In mobile network terminology, that's the IMSI, the International Mobile Subscriber Identity, but it's a number that's uniquely associated with the SIM card in your device, right? That's your identity on a mobile network. The second piece that we collect on a sighting is the identity of the transmitter. So each transmitter in our network has a unique identity. Excuse me. And that identity can be used to provide an approximate location, one of those red circles on the graph. And the third element of a sighting is a time. So you've got identity, you have location, and you have time. That's a sighting. We take a lot of those, and that's the building block of all our analysis. Okay, so what can we infer for the transport industry from my data set? Well, straight away, you can see that I live somewhere just south of Abingdon, in an area south of Abingdon, that I work down in Newbury, that I'm a regular commuter. I use the A34, I commute by car. Sorry, Mark, there's no trains between those two destinations. And from time to time, I make other local journeys, right? So my data set over that week can be split into a series of journeys. And each of those journeys has an origin, a place you start, a destination, a place you go to, and an inferred mode of transport, be it rail or road, and an inferred purpose, commuter, leisure, these types of things. And that's from one subscriber. And if you imagine taking the data from all the Vodafone users in that region, you will build up an unprecedented view of how that transport system is really used. And that is the currency of transport planners. They want to know how the transport system is really used in order to understand how to invest to make it better, right? Now, those journeys, they're aggregated up into patterns called origin-destination matrices. These are provided to local government and civil engineering firms, and they decide how to invest in transport infrastructure based upon those models, right? The picture on the right-hand side, this is a view from a video we have on YouTube, part of our awareness campaign, and it describes a project we did in South Wales. It's the use of the data in this way. We collected it for the South Wales region. We created these anonymisation matrices, and they was then provided to the Welsh Government to help them decide how to invest in that region. If you go to YouTube, type in Vodafone Analytics, you'll probably be the first result. Okay, I went really quickly there, Mark. I rushed through it. This is the bones of the presentation. And what I wanted to do is give you a view of our system and explain how we apply anonymisation in our system. Now, I've broken it into three zones, three secure zones, and I think you refer to them as environments. We have our data collection zone, a data storage zone, and a data processing zone. What I want to do is step through those purple pieces which relate to anonymisation and show you what we do at each stage and why. So I'll start over at this side. This is our mobile network, and from this mobile network we stream basically a fire hose of these sightings events across a whole network, 24/7 from the whole network, from all subscribers. And on that stream of data, the first thing we do in real time is we apply our privacy and permissions rules, and that takes out people who don't want to be in the data set, and also devices that we don't want to be in the data set as well. And that's done right at source on the fly. The next stage, we apply an anonymisation to that device identity, or a pseudo-anonymisation. We use a best practice hashing algorithm. The key is kept secret by a team who have nothing to do with anything downstream. That key is rotated slowly as a matter of course, but we can change it at any time should the need arrive. So we have our hash DMSI at this stage, and that's hash DMSI, the pseudo-anonymized identifier, is moved in that state over to the data storage zone. It only exists in that state for typically a few minutes as it queues to go into our database. And as we load it into our database, we anonymize again, and we convert this hash DMSI into what I'll call an arbitrary integer. And there are two reasons to do that. One is to add an extra level of privacy protection. The second is hash DMSIs are about this long, integers can be about that long, right? So we get a lot of space saving on doing that as well. And we don't just anonymize the identity of the device, we also anonymize the identity of the transmitter everyone connects to, right? So we anonymize that as well. So in our data storage zone, we have an arbitrary integer, and a timestamp, right? We've got a lot of that. It's absolutely useless. It's gobbledygook, right? And that, if you like, is our data lake. We do, of course, keep the key. We keep the key separately. We only keep the key for the location part, so you can convert the identity of the transmitter, to an approximate location. But of course, we want this data to be an anonymized state. We try to abstract it from the identity of any individual totally. So here, we remove all traces of any key back to the individual. The data sits in that data storage. Excuse me. We will persist up to 12 months of data in that state. And if we want to process it, we have a fairly rigorous approvals process. It combines commercial considerations, legal considerations, and also ethical considerations. Once that's approved, a very small number of individuals can say, you know what, please give me an extract of data to do something with in our data processing zone. And those data extracts typically are a geofence, polygon on a map, and a time frame. And for data transport, typically 4 to 6 weeks. So we extract the data, and at this stage, we apply anonymization. We anonymize the identity of the device a third time, so that every data extraction has a different identity for the device to protect against any risk of joining up multiple data extractions. That data is processed. At the moment, we only process it for transport. We create these origin-destination matrices. Once it's done, the data is deleted. And the only thing that's output from our systems is an aggregated view. And we have very strict aggregation rules. And to the point from this morning, I think you asked it, can you tie that up to any other data sources? What we did, I mean, the obligation's on the company, of course. We invited in some third-party cybersecurity experts, and we tried to join that to any social media they could find, right? It's really important that there's no risk. And risk is only a point in time. That it's not risky now doesn't mean it's not risky in the future. So it's a regular process you need to apply. So our aggregated results go out. It goes out to typically local government and civil engineering firms. So that's our system. So I went at breakneck speed. I hope it was interesting. Thank you for listening, and I think I'll take questions at the end of the session. Thank you.
We're taking questions at the end.